Steam once ruled every major railroad in America, and it shaped cities, fueled industries, and defined what progress looked like for generations. Entire towns depended on these machines, and thousands of workers built their lives around keeping them running. Then the 1950s arrived, and railroads began turning against the very engines that had made them powerful, retiring steam at a pace few believed was even possible. How did an empire of iron and fire collapse in less than 10 years? Steam locomotives had ruled American railroads for over a century. These massive machines hauled freight across mountains, pulled passengers between cities, and defined what railroading meant to generations of Americans. The sight of billowing smoke, the sound of rhythmic pistons, and the raw power of steam engines had become symbols of industrial progress that seemed permanent. Every major railroad operated fleets of steam locomotives maintained by armies of skilled workers and facilities built specifically for these machines. But steam power came with serious limitations that became harder to ignore as the 20th century progressed. A typical steam locomotive consumed about 100 gallons of water per mile, requiring railroads to build and maintain water towers at regular intervals along every route. Coaling stations had to be constructed to feed the constant appetite for fuel. Each locomotive needed hours to build sufficient steam pressure before it could begin to work, and the boilers required constant attention from skilled firemen who managed the delicate balance of heat and water. The maintenance demands were enormous. Steam locomotives spent significant portions of their service lives in shops rather than on the rails. The complex machinery of pistons, rods, and boilers broke down frequently and required specialized knowledge to repair. Roundhouses employed hundreds of workers to keep fleets operational, and the infrastructure supporting steam operations represented massive ongoing investments for every railroad. By the late 1940s, railroad executives faced mounting pressure to reduce operating costs while competing against trucks on highways and airplanes in the sky. Steam locomotives, for all their romance and power, were expensive to run and maintain. The technology that had built the American transportation network was becoming a financial burden that railroads simply could no longer afford to carry. Something better had been waiting in the wings for decades, and if you're enjoying this, subscribe so you don't miss the next one. All right, let's keep going. Diesel-electric locomotives offered advantages over steam that became impossible to ignore once railroads saw them demonstrated in actual service. The basic concept was simple. A diesel engine powered an electric generator, which in turn drove electric motors connected to the wheels. This arrangement eliminated the complex steam systems that demanded so much attention and infrastructure. The fuel efficiency alone made a compelling case. Diesel locomotives achieved thermal efficiency roughly 4 times greater than steam, meaning they extracted far more useful work from every gallon of fuel consumed. There were no water towers to maintain because diesels didn't need water for operation. Coaling stations became obsolete because diesel fuel could be delivered by tank car and pumped directly into locomotive tanks. Starting a diesel locomotive took minutes rather than hours. Engineers could walk into the cab, start the engine, and begin work almost immediately. There was no waiting for boiler pressure to build, no careful warming of metal components, no risk of boiler explosions from improper startup procedures. When work was finished, diesels could sit idle without constant attention, ready for the next assignment whenever it came. Multiple diesel units could be connected together and controlled by a single engineer from the lead locomotive. This multiple unit capability allowed railroads to assemble exactly the amount of power needed for any particular train, adding or removing units as loads and terrain demanded. Steam locomotives could double head, but each required its own crew and operated somewhat independently. Maintenance intervals stretched dramatically compared to steam. Diesel locomotives could run thousands of miles between shop visits, achieving availability rates of 90% compared to steam's 50 to 60%. The same number of diesel units could handle more work simply because they spent more time on the rails and less time under repair. In cities, diesels produced far less smoke and soot than steam engines. Regulations like New York City's Kaufman Act of 1923 had already forced railroads to use electric or diesel power in urban terminals, and the cleaner operation of diesels made them better neighbors in populated areas where steam pollution had generated complaints for decades. The numbers made the choice obvious, but railroads still hesitated. The diesel revolution didn't arrive suddenly in the 1950s. Its roots stretched back decades to experimental locomotives that proved the technology could work on American railroads. Understanding why the 1950s became the decisive decade requires knowing what came before. The first diesel locomotives appeared in the 1920s, primarily as switchers working in railroad yards where their ability to start and stop quickly made them useful for assembling trains. Alco built box cab switchers that operated in New York under anti-smoke laws, demonstrating that diesel power could handle real railroad work. These early units were crude by later standards, but they showed the potential. The 1930s brought the streamlined diesel train sets that captured public imagination. The Burlington Zephyr, introduced in 1934, became famous for its sleek stainless steel design and its record-breaking run from Denver to Chicago. Union Pacific's M10000 series offered similar modern aesthetics. These train sets proved that diesels could handle passenger service with style and reliability that impressed both railroads and the traveling public. The breakthrough for freight came in 1939 when Electromotive Corporation introduced the FT locomotive. This 4-unit set produced 5,400 horsepower and toured the country demonstrating its capabilities on the most challenging routes railroads could offer. The FT conquered Raton Pass, climbed the Alleghenies, and it handled heavy freight trains that skeptics thought only steam could pull. Orders began flowing in from railroads impressed by what they witnessed. Then, World War II intervened. The federal government banned production of diesel locomotives for passenger service from 1942 to 1945, directing manufacturing capacity toward military needs. Railroads continued operating their steam fleets, which were essential to the war effort but were wearing out under heavy wartime traffic. The war delayed dieselization but also created conditions that would accelerate it once peace returned. When the war ended, railroads faced worn-out steam fleets, pent-up demand for modern equipment, and demonstrated proof that diesels could handle any service. The explosive growth was about to begin. The 1950s would finish what the 1930s had started. The statistics tell the story of how quickly American railroads abandoned steam power in the 1950s. In 1951, steam locomotives still outnumbered diesels on American railroads, with 22,590 steam units compared to 19,014 diesels. Steam held the edge, but the momentum had already shifted decisively toward diesel. By 1955, just 4 years later, the numbers had reversed dramatically. Diesel locomotives now totaled 26,563, while steam had collapsed to just 6,266 units. The 90% retirement rate for steam locomotives represented one of the fastest industrial transformations in American history. Machines that had been earning revenue in 1951 were sitting in scrapyards by 1955, cut up for metal or rusting on sidings. The pace of retirement during this period was staggering. In the first 10 months of 1952 alone, American railroads retired over 5,700 steam locomotives, and month after month, railroad after railroad announced the end of steam operations on their lines. Photographs from the era showed long lines of locomotives waiting for the cutting torch. Their useful lives ended decades before their mechanical components would have worn out. Some railroads completed full dieselization early in the decade. The Gulf Mobile in Ohio became the first major American railroad to achieve 100% dieselization in 1949, just before the decade began. The New Haven, Texas and Pacific, Delaware and Hudson, Erie and Rock Island followed in the early 1950s. These early adopters demonstrated that complete conversion was possible and economically beneficial. Passenger services led transition because competition from automobiles and airlines made modernization urgent. Sleek diesel streamliners attracted travelers who might otherwise have chosen other transportation modes. Freight services followed as railroads recognized the same efficiency advantages applied to hauling goods as to hauling people. By 1957, even the most committed steam operators had begun converting. Norfolk and Western, which had clung to steam because of its coal hauling business, started dieselizing passenger services that year. By 1960, steam was effectively extinct on major American railroads, surviving only in seasonal service or on small short-line operations. The transformation that seemed impossible had become inevitable. Several diesel locomotive models defined the 1950s transition and became the workhorses that replaced steam across American railroads. These machines represented the state-of-the-art in diesel technology and proved their worth in daily service hauling freight and passengers across the continent. The EMD F7, produced from 1949 to 1953, became the best-selling cab unit of the diesel era. Electromotive Division built 2,393 A units with engineer cabs and 1,463 cabless B units that operated in combination. Each unit produced 1,500 horsepower from the reliable 567 prime mover engine. The F7 handled both freight and passenger duties on railroads across the country, wearing liveries like Santa Fe's famous war bonnet scheme that became icons of the era. The shift to hood units came with the EMD GP7 and GP9, introduced in 1949 and 1954 respectively. These road switcher locomotives offered better visibility for crews and easier maintenance access compared to cab units. The GP9 produced 1,750 horsepower and became one of the most successful locomotive designs ever built, with 4,257 units constructed. Railroads loved their versatility for freight, passenger, and switching duties. Alco competed with the RS3, introduced in 1950 with 1,600 horsepower. This road switcher found buyers across the industry who wanted alternatives to EMD products or who had existing relationships with Alco from the steam era. The RS3 proved reliable and capable, though Alco would eventually lose market share to EMD's dominance. Fairbanks Morse brought the Trainmaster in 1953, offering 2,400 horsepower that made it the most powerful single-engine diesel of its time. Despite its impressive specifications, the Trainmaster sold poorly due to the complexity of its opposed piston engine and maintenance demands that railroads found excessive. The locomotive demonstrated what diesel technology could achieve, but also showed that raw power alone didn't guarantee market success. Baldwin, the legendary steam builder, struggled with diesel engines. Their Centipede locomotives for Pennsylvania Railroad produced 6,000 horsepower, but suffered reliability problems that limited their usefulness. Baldwin's failure to master diesel technology contributed to the company's eventual exit from locomotive manufacturing. These machines would define American railroading for the next 3 decades. The diesel revolution brought efficiency gains that railroads desperately needed, but those gains came at enormous human cost. Thousands of workers lost their jobs as diesel locomotives eliminated the need for skills and facilities that has sustained railroad employment for generations. The fireman position illustrates the change most dramatically. Steam locomotives required a fireman in addition to the engineer, someone who managed the fire and water in the boiler to maintain proper steam pressure. This skilled position demanded constant attention throughout every trip. Diesel locomotives had no fire to tend and no boiler to manage, making the fireman's traditional role obsolete. Unions fought to preserve fireman jobs, winning temporary concessions that kept workers in locomotive cabs as co-pilots, even when there was no fire to tend. These agreements delayed the inevitable but couldn't stop it. The work that had justified the position simply no longer existed, and eventually the jobs disappeared. Maintenance facilities across the country closed as steam operations ended. Roundhouses that had employed hundreds of skilled mechanics, boilermakers, and laborers became obsolete almost overnight. The specialized knowledge required to maintain steam locomotives had no application to diesel technology, and many workers found their skills suddenly worthless in a transformed industry. Between 1947 and 1958, American railroad employment dropped by 38%. The recession of 1958 and 1959 compounded the losses as railroads cut staff to reduce costs during economic downturn. Workers who'd expected lifetime careers with good wages found themselves unemployed with skills that no other industry needed. Communities that had grown up around railroad operations suffered as well. Towns that existed because steam locomotives needed water and coal found themselves bypassed when diesels could run nonstop through their stations. Local economies built on serving railroad workers and travelers collapsed as the trains no longer stopped. Progress came with a price that workers and communities would pay for decades. Not every railroad rushed to abandon steam in the early 1950s. Several major carriers delayed dieselization for reasons that made sense given their particular circumstances, though ultimately, all would make the transition before the decade ended. Norfolk and Western represented the most significant holdout. The railroad hauled enormous quantities of coal from Appalachian mines and had developed some of the most efficient steam locomotives ever built. Their Y6-2882 articulated locomotives produced 132,000 pounds of tractive effort, making them among the most powerful steam engines in service. The railroad's operating ratio of 71.98% in 1953 demonstrated that steam could still be economical when done right. Norfolk and Western argued that burning coal made sense for railroads whose primary business was hauling coal. Purchasing diesel fuel would mean paying competitors while abandoning the product that filled their revenue trains. The argument had logic, but it couldn't withstand the broader advantages that diesel offered. Norfolk and Western began dieselizing passenger services in 1957 and completed the conversion of freight operations by 1959. Pennsylvania Railroad, another major steam operator, took a different approach. Rather than committing fully to one diesel builder, Pennsylvania purchased locomotives from multiple manufacturers, including Alco, EMD, Fairbanks Morse, and Baldwin. This strategy hedged their bets but also created maintenance complications as shops had to support diverse equipment. Their Baldwin Centipedes handled mountain freight but proved troublesome, while EMD products generally performed better. Nickel Plate Road limited diesel purchases to branch line service while retaining steam for high-speed mainline operations. Their S2-284 Berkshire locomotives handled fast freight efficiently, and the railroad saw no immediate need to replace them. This selective approach delayed full dieselization, but recognized that different services might have different optimal power solutions. By the end of the decade, even the most committed steam operators had converted. The economic advantages proved overwhelming regardless of individual circumstances. Steam's defenders fought a losing battle against arithmetic. The diesel transition in Europe during the 1950s followed a different pattern than the American experience. European railroads viewed diesel as a transitional technology on the path to electrification rather than a permanent replacement for steam. This perspective shaped adoption patterns and timing across the continent. Britain's 1955 modernization plan called for significant investment in diesel locomotives, but implementation proved problematic. Early British diesels suffered reliability issues that delayed the promised benefits. The British railway system continued building steam locomotives until 1960, when Evening Star became the last steam engine constructed for British railways. Full withdrawal of steam wouldn't occur until 1968, a decade after American railroads had essentially completed their transition. Germany had pioneered multiple diesel units in the 1930s, with train sets like the Fliegender Hamburger, but post-war reconstruction complicated modernization efforts. West Germany eventually transitioned to diesel and electric power, while East Germany continued building steam locomotives into the 1960s and operated them with cheap lignite coal until the 1980s. The different approach reflected different circumstances. European rail networks served shorter distances with higher traffic densities, conditions that favored electrification over diesel for main lines. About 50% of European rail networks were electrified by the end of the 1950s, with diesel handling secondary routes where traffic didn't justify the infrastructure investment of overhead wires. High-speed diesel multiple units like those used on the Trans-Europe Express provided premium passenger service across borders where different electrification systems would have complicated through operations. These services demonstrated diesel's flexibility, while electric traction handled the heaviest traffic corridors. The European experience showed that dieselization was not only the path forward from steam, but that it remained essential for routes where electrification proved impractical. Different railroads found different paths to the same destination. The financial impact of dieselization reshaped the American railroad industry in ways that extended far beyond locomotive purchases. Operating cost reductions reached 50% in some operations, fundamentally changing the economics of rail transportation. Fuel efficiency provided the most obvious savings. Diesel locomotives extracted more useful work from every dollar spent on fuel, and the simplified fueling process eliminated infrastructure costs that steam had required. No more water towers to maintain, no more coaling stations to operate, no more armies of workers managing fuel and water supplies at stations across the network. Higher availability multiplied the savings. Because diesel locomotives spent more time working and less time under repair, railroads could handle the same traffic with fewer units. A fleet of diesel locomotives might accomplish what a larger fleet of steam engines had handled, reducing both capital investment and maintenance expense. The 90% availability rate for diesels compared to 50 to 60% for steam translated directly into financial advantage. Longer runs between stops improved efficiency further. Steam locomotives had to stop regularly for water and coal regardless of whether passengers or freight needed to board or depart. Diesel locomotives could run nonstop for hundreds of miles, reducing journey times and operating costs simultaneously. The 3,200-kilometer runs common in North America demonstrated capabilities that steam could never have matched. However, the transition also imposed costs. Railroads had to finance diesel purchases while writing off steam locomotives that still had mechanical life remaining. New maintenance facilities designed for diesel technology required capital investment. Some railroads struggled with the financial burden of rapid conversion even as they recognized its necessity. The broader economy felt impacts as well. Declining coal demand hurt mining regions that had supplied railroad fuel for generations. Oil refineries gained new customers as diesel fuel consumption increased. The shift in energy sources rippled through industries far from the railroad tracks where the visible changes occurred. The savings were real, but the transition was expensive. By the late 1950s, steam locomotives were vanishing from American railroads so quickly that enthusiasts began documenting what remained before it disappeared entirely. The final runs of famous locomotives became events that drew crowds of photographers and rail fans who understood they were witnessing the end of an era. Norfolk and Western operated the last major steam service on a Class I American railroad, running its powerful articulated locomotives on coal trains until 1959. The railroad's efficient steam operations had held out longer than any other major carrier, but even they couldn't resist the economic pressure indefinitely. The final regular steam runs marked the end of an operational philosophy that had delivered impressive results but couldn't continue. Smaller railroads kept steam running into the 1960s. The Duluth, Mississippi, and Iron Range hauled iron ore with steam power into the early 1960s, finding the heavy locomotives well suited to their demanding service. Colorado and Southern operated 280 number 641 until 1962 on branch line freight. These holdouts provided opportunities for enthusiasts to see and photograph working steam when it had disappeared everywhere else. Industrial operations preserved steam longest of all. Northwestern Steel and Wire in Illinois operated former Grand Trunk Western switchers until 1981, providing what enthusiasts called the last everyday steam operation in the United States. These industrial survivors existed because their owners found no compelling reason to invest in replacements for equipment that still worked. The preservation movement grew directly from the 1950s dieselization. Enthusiasts who watched beloved locomotives head for scrapyards began organizing to save examples for future generations. Museums acquired significant steam engines, and excursion operations emerged to give the public opportunities to experience what regular railroad service no longer provided. The romance of steam became valuable precisely because it had become rare. The machines that had been common working tools transformed into treasured relics almost overnight. What railroads discarded, enthusiasts scrambled to save. The 1950s diesel craze buried steam power so completely that within a single decade, the technology that had built American railroads became a museum curiosity. The transformation happened because diesel locomotives offered advantages that no amount of steam engineering could match. Efficiency, availability, and economics drove decisions that reshaped an industry and changed the landscape of American transportation forever. Do us a favor and hit that like button and subscribe for more stories of the machines that transformed American history.